Alright, so we are going to talk about your Conceptual Unit 6 review. First question says, simplify the rational expression. Find all numbers that must be excluded from the domain of the simplified rational expression. So first of all, they want me to, let me get a pen here. They want me to simplify the rational expression. What that means is you factor the top and you factor the bottom and you see if any factors cancel, and then what's left is your simplified answer. So on top, it should be an easy factor because a is 1. So y times y is y squared. Factors of 28 that make 11 would be 7 and 4. Since c is positive, they both get the middle sign. And my top is simplified. Bottom should be an easy factor because the a is 1. Y times y. Factors of 8 that make 2 would be 2 and 4. Since c is negative, only the bully gets the positive, and 2 is going to be the negative. And so now that you've factored the top and factored the bottom, you can see that the y plus 4 factors cancel. And my simplified answer is y plus 7 over y minus 2. To find the numbers that must be excluded from the domain, you say Mr. Denominator, which is all of this before it got canceled. You say Mr. Denominator, you may never equal 0. And then each factor can't be 0. So y minus 2 can't be 0, and y plus 4 can't be 0, which means add 2, y can never be 2, minus 4, y can never be negative 4. So y can't equal 2 or negative 4. Okay? Alright, number 2. This is multiplying. When you multiply, it is straight across the top, so top times top, bottom times bottom. And the multiplying is done. Alright, all I need to do, you could FOIL, you could distribute, not FOIL, but you could distribute if you wanted to, but that's just going to make it worse to factor. The trick is to factor all the factors. So, if I look at this factor, that should be an easy factor because a is 1, x and x. Factors of 24 that make 10 would be 4 and 6. C is positive, so both get the middle, and that factor's done. If I factor this factor, that's difference of squares, so bino, plus n, mino. X times x is x squared, 1 and 1 is 1. Okay, and then on bottom, bloop. If I factor this factor, should be an easy factor because a is 1. Factors of 4 that make 3 would be 1 and 4. C is negative, so only the bully gets the middle, so 4 is minus, x is plus. And then if I factor the last one, I'll keep that in red. Difference of squares, bino, plus n, mino. Square root of x squared is x, square root of 36 is 6. So I factored all the factors on top and all the factors on bottom, so now we can cancel. X minus 4 is gone, x minus 6 is gone, x plus 1 is gone, and what's left is x plus 1 over x plus 6. But to make your list of everything that your denominator can't be, you say Mr. Denominator before you canceled. So you say x plus 1 times x minus 4 times x plus 6 times x minus 6 can never equal 0. Which means x can never equal negative 1, x can never equal 4, x can never equal negative 6, and x can never equal positive 6. So that's where this came from. Okay? Alright. And number 3. Now we have to divide. So here we're going to change division to multiplication, and we're going to flip the last one. Okay, so if I rewrite this, I have 6x squared plus 4 over x minus 4 times, instead of divide, and then I flip the last one, is going to be x squared minus 16 over 9x squared plus 6. So there's your first step, is to keep change flip. And now you have top times top, bottom times bottom. So now we're right back to what we just did. We have to factor all those factors. So in blue, that's two terms, which should be an easy factor, GCF times what's left. They have a 2 in common. If I factor out a 2, that's going to leave 3x squared plus 2. If I factor, let's see, let's do blue. If I factor the light blue one, that's difference of squares, bino, plus n mino, x times x, and 4 times 4 is 16. On bottom, x minus 4 is prime. I can't factor that, so that's going to stay x minus 4. And over here in purple, that should be a GCF times what's left. They have a 3 in common. If I factor out a 3, that would be 3x plus 2. 3x squared plus 2, sorry. And now I can cancel like factors. The 3x squared plus 2 is gone. The x minus 4 is gone. So I'm left with 2 times x plus 4 on top and a 3 on bottom. And what I say is Mr. Denominator, which was x minus 4 times 3x squared plus 2, can never equal 0. Oh, ew, no. You have to go with your original, which are these two denominators. So you say x minus 4 and x squared minus 16 can never equal 0, which this says x can never equal 4. And this, if I solve it, add 16, x squared can never equal 16, square root, x can never equal plus or minus 4, which we already had a plus 4 here. So the ones that have to be excluded is x can never equal 4 or negative 4. Alright, so now we've got subtraction and the denominators match. If the denominators match, keep the denominator and you subtract the tops, which is going to be x squared, sorry, I wanted a different color, x squared minus 5x minus x minus 5. Be careful of that subtraction. I've noticed in looking at some of y'all's work that you minus the x, but you don't minus the negative 5. On top, to simplify that, distribute. Nothing distributes on the first one, so you have x squared minus 5x. If I distribute that negative, that gives me a negative x and a positive 5. On bottom is x squared minus 2x minus 15. On top, we're going to combine like terms, which gives me x squared minus 6x plus 5 over x squared minus 2x minus 15. And we're done adding and subtracting. However, the last thing you need to do is try and factor the top and factor the bottom to see if anything cancels. Top should be an easy factor. A is 1, so x times x. Factors of 5 that make 6 would be 1 and 5. C is positive, so they both get the middle. Top is done. Bottom should be an easy factor because A is 1, so x times x. Factors of 15 that make 2 would be 3 and 5. C is negative, so only the bully gets the minus and 3 gets the plus. And you can see that I can cancel the x minus 5s, which leaves me x plus 1 over x plus 3. My denominator, x plus 3 times x minus 5, can never equal 0. So x can never equal negative 3, and x can never equal 5. Okay? Alright, so it says perform the following operation. Now they want me to add, but the denominators don't match. So your first step is to factor every denominator you can. I can't factor 5x plus 4. They have nothing in common. Over here, I can factor, that's difference of squares, so that's going to be bino plus n mino. Square root of 25x squared is 5x. Square root of 16 is 4. So, arugula, when you're adding and subtracting, you're not making a kill list, you're just making a list of what everybody wants in their denominator. And Barugula says, Daddy, I want a 5x plus 4. Daddy, I want another 5x plus 4. No, you already have one. Daddy, I want a 5x minus 4. So he gives Barugula her denominator, 5x plus 4 times 5x minus 4. Then the girls look at her and they want the same denominator. Well, this one, number 1, has the 5x plus 4. It needs the 5x minus 4. So I give it to her. But I got to do it on top and on bottom. This denominator has the 5x plus 4, has the 5x minus 4, so she gets nothing. She already has everything that Barugula wants. Okay? So now, the denominators all match. She's got them, and Barugula has them. So we keep that, and we do the math on top, which says, 5x minus 4 times 5 plus 5x. Okay, so I just copied the numerator problem because I keep the denominator the same. Okay, so then I simplify the top. Distribute, I get 25x minus 20 plus 5x over 5x plus 4 times 5x minus 4. And the adding is done. I just need to factor on top and on bottom and see if I can't get anything to cancel. So I can combine x's. That's going to give me 30x minus 20 over 5x plus 4 times 5x minus 4. So I combine like terms. Now I'm going to see if I can factor it. 2 terms, if I can do anything, is a GCF times what's left. They have a 10 in common. If I pull a 10, I get 3x minus 2. And on the bottom I get 5x plus 4 times 5x minus 4. Nothing cancels, so in factored form, that's my solution. And then to get what my x can't be, I say, Mr. Denominator, 5x plus 4 times 5x minus 4, you may never equal 0. So if I do the math on each one, this one I would subtract 4. 5x can never equal negative 4, divide by 5. X can never equal negative 4/5. Solve this one, add 4, so 5x can never equal 4, divide by 5. X can never equal positive 4/5, which is how they got that. Okay? Alright, so this one they want me to subtract, and the denominators do not match. So my first step is to factor every denominator. So I've got 3x over, should be an easy factor. Factors of 21 that make 4 would be 3 and 7. C is negative, so only the bully gets the plus. 3 is going to get the minus. 2x over, this should be an easy factor. X and x. Factors of 12 that make 1 would be 3 and 4. C is negative, so only the bully gets the middle. 3 doesn't. So now we're going to make a list, not a kill list. You only make a kill list when you've got an equal sign. We're just making a list to get the same denominators. So my list, Daddy, I want an x minus 3. Daddy, I want an x plus 7. Daddy, I want another x minus 3. He says, no, you already got one. And Daddy, I want an x plus 4. So that's what Barugula wants. She wants an x minus 3, an x plus 7, and an x plus 4. Okay, so now you go and you make their denominators look like hers. First girl has the x minus 3 and the x plus 7. She's missing an x plus 4. So I give her an x plus 4 on top and on bottom. My second girl, she's got the x minus 3 and the x plus 4. She's missing an x plus 7. So give it to her on top and on bottom. And now check to make sure. Do your denominators match? Yes, they do. They all three have the same bottoms. So now I'm allowed to do the math on top, which says x plus 4 times 3x minus 2x times x plus 7. Okay, so now if I simplify on top, I have distribute, I get 3x squared plus 12x distribute the negative 2x, I get negative 2x squared minus 14x all over x minus 3 times x plus 7 times x plus 4. So on top, I'm going to combine like terms, and I get 3x squared minus 2x squared is x squared. 12x minus 14x is minus 2x over x minus 3 times x plus 7 times x plus 4. I can try and factor the top two terms would be GCF times what's left. I can factor out an x, which leaves x minus 2, all over x minus 3, x plus 7, x plus 4. Nothing cancels, so I am done. And then to get what your denominator can't be, you say, Mr. Denominator, you may never equal 0, which says x may never equal 3, x may never equal negative 7, x may never equal negative 4. And that's where they got those from. Alright, number 7 says complete parts A and B for the following question. A. Write the value or the values of the variable that make a denominator 0. These are the restrictions on the variable. So you say, Mr. Denominators, you may never equal 0. Okay, so I set each denominator, tell it can't equal 0, and get x alone. Minus 14. 7x may never equal negative 14. Divide by 7. X may never equal negative 2. Minus 2, minus 2. X may never equal negative 2, which I already knew. This doesn't even have an x in it, so there's no drama, no restrictions. So the restrictions are x can never equal negative 2. Now to solve it, okay, we want to factor every denominator. So I have 6 over, I can pull a 7, which would leave x plus 2, equals 6 over x plus 2 minus 3 over 7. Now that we have an equal sign, now we're making a kill list. And my kill list is, Daddy, I want a 7. Daddy, I want an x plus 2. Daddy, I want another x plus 2. No. Daddy, I want another 7. No. So now, instead of making all the denominators look the same, which is what you have to do when there's no equal sign, we can kill with it. So you multiply everything through by a 7 and an x plus 2, a 7 and an x plus 2, a 7 and an x plus 2. Then die or multiply. So here the x plus 2's are gone and the 7's gone, which leaves me 6. Here the x plus 2's are gone, which leaves me 6 times 7. Here the 7's are gone, which leaves me negative 3 times x plus 2. So I cleared the fractions. Now I can solve the problem. So I have 6 equals 42 minus 3x minus 6. Distribute and multiply. Combine like terms. So I have 42 minus 6, and that's going to be, I think, 36, yeah, 42, I just don't want to make mistakes, yeah, 36 minus 3x, so to get x alone, I'm going to minus 36, that gives me negative 30, equals negative 3x, divide by negative 3, and x equals 10. And as long as it's not in my list, which would say, that doesn't say anything, there's no x, but this says that, well, yeah, x can't be negative 2. We already found that out. So I can keep my answer. Alright? Same thing. Alright? The values that make the denominator 0, you set each denominator and say you may not equal 0, you may not equal 0, and you may not equal 0. So when we solve these, we get x can never equal negative 9, x can never equal 9, x squared can never equal 81, I added 81, square root, x can never equal plus or minus 9, which is what I already had. So x can never equal 9 or negative 9. And then to solve it, okay, we got to factor every denominator, so I have 4 over x plus 9 minus 3 over x minus 9 equals 4x over bino plus n minus x plus 9, x minus 9. So now when I make my kill list, Daddy, I want an x plus 9. Daddy, I want an x minus 9. Daddy, I want another x plus 9. No. Daddy, I want another x minus 9. No. So we multiply through by the list. X plus 9, x minus 9, x plus 9, x minus 9, x plus 9, x minus 9. Cancel and multiply what's left. The x plus 9s are gone, which leaves 4 times x minus 9. On the second one, the x minus 9s are gone, which leaves negative 3 times x plus 9. And on the end, they both cancel, which leaves just plain old 4x. No more fractions, so we solve. I'm going to distribute, I get 4x minus 36 minus 3x minus 27 equals 4x. Combine like terms. 4x minus 3x is x. Negative 36 minus 27 is negative 63 equals 4x. So now I'm going to get x alone, so I'm going to minus x. I get negative 63 equals 3x. Divide by 3, and x equals negative 21. And it's not in my I can't use list, so I can keep it. Okay? Alright, so now if we do this one, the values, I say, Mr. Denominator, you can't be 0. The next denominator cannot be 0. And if I factor this, x and x, factors of 10 that make 3 would be 2 and 5. Fully gets the middle. So this cannot equal 0 either. I just factored it first while I was going, since I was going to have to factor it anyway. So this says x can never equal 2. This says x can never equal negative 5. This says x can never equal 2, and x can never equal negative 5. So x can never equal 2 or negative 5. Okay, so now if I solve it, okay, I'm going to rewrite it, which I already factored that for myself. So that's going to be 1 over x minus 2 minus 4 over x plus 5 equals 7 over x minus 2 times x plus 5. When we have an equal sign, we make our kill list. Daddy, I want an x minus 2 and an x plus 5 and another x minus 2, no, and another x minus 5, no. So we multiply through by our kill list. X minus 2 times x plus 5, x minus 2 times x plus 5, x minus 2 times x plus 5. Cancel and multiply what's left. The x minus 2's are gone, so I'm left with 1 times x plus 5. In the middle, the x plus 5's are going to cancel, which leaves me negative 4 times x minus 2 equals, they both cancel, and I'm left with just 7. Okay, so we cleared the fractions. Now we're going to solve. So I have distribute, x plus 5 minus 4x plus 8 equals 7. Combine like terms. X minus 4x is negative 3x. 5 plus 8 is 13 equals 7. So now I'm going to minus 13. I get negative 3x equals negative 6. Divide by negative 3. And that gives me x equals 2. But this says that x can never be 2, which means I have to throw it out, which means there is no solution. Okay? Same thing here, it's just now when you're done you have to decide whether it's an identity, a conditional, or inconsistent equation. So it says, I don't have to find the, well, I'm going to have to find them anyway, but, okay. So my kill list would have a 2 and a 3 in it. So 2 times 3, 2 times 3, 2 times 3. The 2's cancel, that leaves me with 3 times x plus 7. Nothing cancels, so that leaves me a negative 7 times 2 times 3. The 3's cancel, and that leaves me 2 times 2x minus 6. We cleared the fractions. So now simplify. I have 3x plus 21 negative 7 times 2 times 3 is going to be negative 42 equals 4x minus 12. Combine like terms. I have 3x minus 21 equals 4x minus 12. Get my x's together. I'm going to minus 3x minus 3x. I get negative 21 equals x minus 12. Add 12. Add 12. I get x equals negative 9. And as long as I don't have to throw it out, then I can keep the answer, which makes it conditional. And I don't have to throw it out. There's no drama. There's no x's in any denominator. So there's nothing that can't be in the domain. Okay, so I get an answer that I can keep, which makes it a conditional equation. Okay, this one says write the equation being solved. Well, remember, this was your y1, this was your y2, and when you do this, you're trying to figure out when they're equal. So the equation that they're trying to solve is y1 equal y2. That's what they're trying to solve. Now, to solve it, you're looking for y coordinates that match. Nope. Yep. Nope, 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 nope. So my solution has to be, since those y's match, x has to equal negative 1.5. Okay? Alright, this one says find the domain of the following rational functions. To find the domain, we say Mr. Denominator, you may never equal 0. So this says x may never equal 1, and x may never equal negative 3, and that's your domain. Okay? Yeah, remember they write it the set of all x such that x can never equal 1 or negative 3. Alright, so the domain on this one, we say Mr. Denominator, you may never equal 0. Solve that. Minus 6, x squared can never equal negative 6. Square root. X can never equal plus or minus the square root of 6i. So the only thing that has to be eliminated are imaginary things which don't exist, which means there are no restrictions on the domain. There's nothing that would cause my denominator to go to 0. Well, it would, but it would have to be something imaginary, and that doesn't exist, so I don't need it. Okay, so now they want the vertical asymptotes. For vertical asymptotes, you set denominator equal to 0. It's almost like finding the domain, except for instead of saying what x can't be, what you're finding is when you get zeros in the denominator, you're finding asymptotes. So you say, Mr. Denominator, when you do equal 0, I will get vertical asymptotes. And that's going to be when x equals 0 or x minus 4 equals 0, which would be when x equals 4. Okay, now you got to pay attention to the whole thing. Alright, if you factor the bottom, which it already is, I can't factor it anymore, does either of these factors cancel with anything on top? No. If nothing cancels, you will have no holes. So you'll have asymptotes at 0 and at 4. And you can't just put 0 and 4, you have to put x equals 4 and x equals 0. Okay? Alright, so to find the vertical asymptote here, we're going to say Mr. Denominator, you may never equal 0. To solve a second degree, factoring should be easy because a is 1, x and x. Factors of 21 that make 10 would be 7 and 3. Since c is positive, they both get the middle, which says x can never equal negative 7 and x can never equal 3. What that means is I will have a vertical asymptote at x equals 7 and at x equals 3 unless one of them turns into a hole. To see if any of them turns into a hole, you have to factor the top, factor the bottom, which I already did, and see if any. and see if anything cancels. And the x minus 7s would cancel, which means this one becomes a whole instead of an asymptote. This one didn't cancel, so that's going to stay an asymptote, and that one turned into a whole. Okay? Alright, so this one says, find the horizontal asymptote if any of the degree of the graph of the rational function. For horizontal asymptotes, you use your degree rules. If the top degree is smaller than the bottom degree, then y equals 0. If the top degree is equal to the bottom degree, then y equals TLC over BLC. And if your top degree is bigger than your bottom degree, there is no horizontal asymptote, but there will be a slant asymptote, an oblique one. Okay, so for this one, to find the horizontal asymptotes, we look at my degrees. My top degree is 1, my bottom degree is 2. Since top degree is smaller than bottom degree, my horizontal asymptote's at y equals 0. Alright, oops, did I skip one? Yeah, 17. Find the horizontal asymptote here. My top degree is 3, my bottom degree is 2. Top degree is bigger than bottom degree, so there is no horizontal asymptote. Okay, on this one we have my top degree is 1, my bottom degree is 1, exponents or degrees. They're equal, so y equals my TLC divided by my BLC. My top leading coefficient is -7, and my bottom leading coefficient is +5, so y equals -7/5 is my horizontal asymptote. Okay, and then last one, you got to do this 7-step method to describe. Okay, so to find the symmetry, and I know in the lesson I kind of skipped that, but at least on the recorded one. To find the symmetry, you find f of -x. So that would be 2 times -x over -x squared minus 16. This becomes -2x. This becomes +x squared minus 16. I don't know why they're saying it's an odd, because he changed signs and he didn't, and he didn't. So some did and some didn't, which should make it neither. Huh. Okay, what I'm going to suggest we do for symmetry is wait until we graph it and look at the graph. So we'll talk about it when we get to the end. Okay? Alright, so then we find the y-intercept, so we do f of 0. That would be 2 times 0 over 0 squared minus 16. That would be 0 over -16, which is 0. So the y-intercept is 0. To find the x-intercept, you set your numerator equal to 0, divide by 2, and my x-intercept is also 0. To get my vertical asymptotes, we set denominator equal to 0 and solve. Add 16, square root, x equals plus or minus 4. So you're going to get vertical asymptotes at plus or minus 4. And then I'm going to continue on the next page. For 5, the horizontal asymptotes, here's my function again. So I look at my top degree is 1, my bottom degree is 2. Top degree is smaller than bottom degree, which means y equals 0 is my horizontal asymptote. So now to graph, okay, and we didn't do this very much because I know you guys aren't going to like plugging in points. You can do it mathematically. They already picked the points they want you to plug in. So if I plug in -5, I would have 2 times -5 over -5 squared minus 16. That would be -10. That would be 25 minus 16, which would be 9. Now, the problem is, -10 ninths, how in the heck are you supposed to graph that? I mean, -5 and -10 ninths. That's -1 and a little bit. Okay? So they put it right there. What I'm saying is, this isn't this hard, but use your calculator. Again, I don't think they're going to do this to you on the EOC because they're not going to give you these calculators. I mean, yeah, you can figure it out, but you're matching graphs, okay? So you know that we're going to have boomerangs probably, and obviously according to this, we're going to have boomerangs and an S in the middle. So the Math Excel is going to make you generate these points, but let me tell you a secret on how to pick the graph out if you're picking. Do you see how this whole fraction in my function, I got 2x over x squared minus 16. You see how this whole fraction is positive? If the whole fraction is positive, then I promise your boomerangs, wherever your boomerangs are, have to be boomeranging this direction, up. If that fraction was negative, see how these boomerangs are reflecting this way? Okay, this would be when you have a negative fraction. Your boomerangs will reflect and go opposite. If you have a positive fraction and you're matching graphs just by eyeballs, in this case it was easy to pick because these two both would have to have a negative fraction to boomerang this way. So I know it's got to be C. Okay? And again, with us, with the technology that we have, other than on your quarter benchmark, for my test, you just type this in the calculator. Next to y1, you would type parentheses 2x parentheses divided by parentheses x squared minus 16 and graph it. Okay? But let me show you on the calculator how you can type these in so you don't have to do the math by hand and freak out. Alright? See how I typed? Just you got to be really careful. It's hard to read the top ones because they didn't all fit because of the negatives. But look down here when I started plugging in 0.5. So notice how I put parentheses around the numerator and I put parentheses around the x. Okay? And here I put parentheses also around the x squared. So you type it just like that. And you see how it gives me, it'll give me the decimal, which helps me freaking graph easier because now I can see at -5 it's -1.1. -5, -1.1 is about right there. Okay, when I plug in -1, I got 2/15, which is 0.133. So at -1 over here, I get, what was it, 0.133, which is barely above, yeah? And then we plugged in 0.5, and we got -4/63, which is -0.6. So at +1, it's negative down here a little bit. Okay, and then at +1, I plugged it in, I got -0.1333, so at +1, it should be about right there, it's going to be -0.06. These are too close to even graph. And then at 5, it's going to be 1 point something. Yeah, 1.1 something. And so then you're supposed to know, well, since I got that, it boomerangs here. To go through there, it's got to make an S shape, and this one's got to be the boomerang up here. Okay? Alright. And then I typed it in the calculator like that, and got the graph. Okay, so that is your review. Happy homeworking, and I will see you next time.